So we are in the inaugural session for blockchain demystification. And as we have discussed, we are going to talk about private versus public blockchains.
Yep.
Okay, and we are recording your words of wisdom so that we can transcribe them and have that as part of a broader series of conversations where you explain blockchain and folks would understand.
Sounds good.
Okay, so let's go.
Cool. So what I wanted to do was sort of start from the beginning, giving a little bit of history of what blockchain technology is and where it came from. And all of that relates to ultimately to the difference between public versus private blockchains, which recently, as we've seen, has caused a lot of confusion with the clients that we've talked to. And one thing I want to point out is, although private and public blockchains all fall under the umbrella of blockchain technology, they really are kind of two completely different types of technology that use totally different types of underlying kind of theory, and they use different types of, like, the building blocks behind them are completely different, and they really solve different problems. So it's almost unfortunate that you have one word that describes these two different classes of technologies, since they're different types and they solve different problems. But at the same time, it's also starting a lot of conversations and has a lot of excitement. So I guess as we go through this, please interrupt me and just ask questions, because I realize it can be kind of confusing. There's a lot of this. Blockchain technology touches upon advances from a few different fields in computer science, including databases, distributed systems, computer networks, and cryptography. It's sort of blockchain technology sits at the intersection of these different fields. So it all started with Bitcoin. So Bitcoin is a distributed or decentralized peer-to-peer payments network. So it was originally a paper that was created by this anonymous person, Satoshi Nakamoto, who posted this paper on sort of email and web forms, and it came out of there's sort of a movement called the cypherpunk movement, which were a bunch of cryptographers that were really interested in developing new cryptography and how cryptography could affect society. And peer-to-peer electronic payments that was decentralized, and we'll get into what decentralized means in a minute, was sort of one of the kind of ultimate visions of the cypherpunk movement, being able to send payments electronically and not have anyone know who you are, and be able to stop your transactions and not have to pay huge fees. This was something that the cypherpunk movement has always been interested in since the 80s. And Satoshi Nakamoto submitted this paper and code, and open sourced this code, and Bitcoin was born. And Bitcoin, that network, solved several problems that people thought up until that point were impossible to solve for peer-to-peer electronic payments. So real quick, decentralization, what that means is that there's no single organization that controls or operates the entire system. So there's plenty of technologies that are distributed, but not very many that are decentralized. So distributed just means more than one computer. Distributed means you have multiple computers that are working together to solve a problem. but more often than not, those computers are all owned and maintained and operated by a single organization. So there's many distributed databases where you run multiple computers to run a single database, and it's distributed. So if one computer fails or the power goes out at a location, you still have your database. That's been around for a very long time, and you have one, IT group that, maintains that database, and typically it might be an Oracle database or what have you, but it's distributed. Decentralized is is similar, but it's also very different. Decentralized means that more than one different group or organization or person owns and operates it. So the most prominent decentralized technology that we use every day is the internet. So although there are groups of people that come together and decide standards for the internet does not have one governing entity that owns and controls it. You can just go and buy a router from the store and connect to the internet. I mean, there's a certain number of ISPs, but you can also create your own intranet or private using the same technology and create your own private network if you want. But the important thing is there's no governing body. It's a bunch of different organizations that all run infrastructure that connects together and allows people to communicate digitally. So that's probably the best example of a decentralized technology. So in going back to Bitcoin, Bitcoin is decentralized, meaning anyone can go out and run a Bitcoin node and participate in that network. And it's the key invention behind Bitcoin is the consensus algorithm. What a consensus means is just, and we'll go into probably more detail in a separate session, but consensus just means how different people reach agreement on something. So everyone is running software that executes a protocol, which is just an agreed upon series of steps. If this happens and this other thing happens, it's just code that everyone's running on their computers. And the consensus bit determines how the nodes reach agreement. And the reason why that's tricky is because you don't know who the other people are, and people misbehave. So the key, before Bitcoin, people didn't think doing electronic peer-to-peer payments was necessarily even possible because of this consensus problem. The challenge of getting a bunch of people who you don't know who they are reach agreement on, in this case, how much Bitcoin someone has. So account balances. So Bitcoin ultimately maintains a database where for each, they call it wallet, but you can think of the amount of money each person has, kind of like a bank account. They call them wallets, but how much money is in each wallet? So at the end of the day, what the Bitcoin network is doing is it's allowing a bunch of people who don't trust each other reach agreement as to how much money everyone has. And it has to do that in a way, in an environment that's very hostile, meaning people don't trust each other, people are lying to each other, they're trying to cheat each other, they're trying to hack each other and steal each other's money. People are trying to mint new money, make their own fake money, all of the above. And the challenge that Bitcoin solved was the consensus part, where so if you think of everyone, you download your software, your Bitcoin software, you download it, it's creating this database of all the different account balances. Everyone else is doing the same. So they all have the software, it has a database of all the different account balances. We'll go into more detail later on that, but everyone has their own database of all the account balances. And their software is running this consensus protocol or consensus algorithm, just an agreed upon set of steps coded in the software that determines how all these databases reach agreement and see the same thing. Because it's really important that what you see in your database that says how much money I have is the same that Hossein sees. Because if there's a discrepancy between those two, then Bitcoin isn't very useful, right? Mm-hmm. Because it means that I can lie. I can say I have more money than I actually do, and I can spend, money. I can double spend money. I can spend money I already spent, or take money away from people. So it's really important that everyone that participates and runs a node is seeing the same thing. They have the same database. The database says that everyone has the right amount, and the way they reach agreement is through what's called the consensus protocol. It's just the algorithm or the steps that the software runs to make sure everyone is in agreement. So ultimately, like in the Bitcoin network, what ends up happening is once the transaction has been agreed upon, you end up updating your database of these account balances. So part of this agreement is verification of the transaction. So you want to make sure, does Hossein have 1,000 pounds to send? Mm-hmm. Is Hossein the actual person that's sending the 1,000 pounds? Is it actually his money, or is he pretending to be someone else? Those are the types of validations that would happen with the transaction. And then once the transaction is executed, you'd say, okay, deduct 1,000 pounds from Hossein's wallet and add 1,000 pounds to Julia's wallet. Mm-hmm. So your underlying database gets updated, and everyone is doing this in the network.
Yeah.
I mean, not exactly at the same time. We can talk about that later, but pretty much at the same time. Mm-hmm. Updating so that, okay, this money has been moved from this account to this other account. Now, the key innovation in Bitcoin was Satoshi developed a new type of consensus protocol that was unknown until that paper was released, and that's this proof of work thing. Mm-hmm. So, in all of the traditional, consensus is a problem that has been in computer science for a very long time, in other areas too, other fields too, and all the kind of traditional approaches to consensus typically were around the idea that you knew the identities of the participants. So you know that, okay, there's these 5 or 6 people, you know who they are. Some of them might be malicious, they might be lying to you, but you know who's who. You know the participants ahead of time. Mm-hmm. Okay. Most of the consensus research was around that type of formulation. In Bitcoin, it's what they call pseudo-anonymous, but the point is you have no idea who the people are in the Bitcoin network. Mm-hmm. Everyone is identified through, you can think of it as a random ID. They have some large random number, and that's their ID. And someone can have multiple IDs. They can pretend to be 100 different people or 1,000 different people. Like, you have no idea. Mm-hmm. And proof of work allows a group of people to reach consensus even when you don't know the identities of the people participating, or whether they're even, or whether or not they're pretending to be a bunch of different people. So if you think of like a normal, like the algorithm that Hossein said, everyone votes, right? Mm-hmm. Well, on the internet, there's a famous joke, like nobody knows you're a dog on the internet. Like on the internet, you can pretend to be whoever you want, right? Mm-hmm. So you can't really use a voting approach because I can just pretend to be 1,000 different people.
Yeah.
I mean, Twitter is having this problem right now with this whole Russia stuff where you have all these sock puppets, people pretending to be, mean, you have these troll farms where it's like people pretending to be thousands of different people, and it's only like a few hundred people, like just creating a bunch of fake accounts.
Yeah.
Right. So if you use a voting-based approach, you can't just use majority vote because you don't know if like someone's pretending to be 10,000 people.
Yeah.
The internet doesn't have an identity layer.
Mm-hmm.
So in the internet, it's just IP addresses, just addresses. There's no way of knowing like that the person you're talking to maps to some real world person. So Satoshi introduced this concept called proof of work, which allows groups of people to reach consensus and agreement even when you don't know the identities of the people and people are faking and pretending to be other people.
Mm-hmm.
So this faking and pretending to be, that's called a Sybil attack, Sybil, S-Y-B-I-L. It was named, it's kind of, you might see that show up in, I don't know, elsewhere, but it was named after a woman in the U.S. who had multiple personalities and pretended to be a bunch of different people and stole money, I guess, from banks or something by having this pretending to be multiple people.
And
it's the same idea. Like it shows up on the internet like all the time.
And Sam, one other question. Now, you say with Bitcoin or like blockchain, you can kind of check that one person is not pretending to be another one or 1,000 or whatever. And how does that work? Like how can you check that?
The thing is you can't. So Bitcoin, Satoshi, he didn't try to do that because at the end of the day you really can't check that someone is who they say they are.
Yeah.
When you don't know the identities of people.
Yeah.
So the way proof of work, the way that works is people, so what ends up happening, okay, so this is going to start to get a little technical, but in the Bitcoin network, people create transactions. So transactions, like anyone can. Like you download Bitcoin and now you create a transaction. What the transaction says is, the simplest type, it just says, send this many coins to, this person, right? And you submit that transaction to the network. All that means is when you join the network, you have a number of peers. These are other nodes on the network that you connect to.
Mm-hmm.
Typically, it's like between 8 to 10 peers, like a handful of peers that you connect to. When you first download your software, you connect to these 8, let's say dozen peers. You create a transaction and you send that transaction, you broadcast it to your peers, right?
Mm-hmm.
Now, that doesn't mean your transaction has been verified or executed yet. You just sent it out to the network. Now, what happens is there are special nodes called miners that bundle up, that collect these transactions. They do some quick verification, make sure, okay, does this person actually have the coins? Is it like, is the amount they're sending greater than 0? They're not trying to send like a negative amount or something weird like that. Like there's some basic validation rules. But the miners, these special nodes, you can think of them just as special nodes in the network. They collect a set of transactions, and then they create a bundle of transactions that's called a block. Okay, so they collect all these transactions together, they group them together, and now they have something called a block, right? Now, before they can propagate the block, and before the block is valid, they have to go through this energy-intensive task of basically finding a random number that has special properties. I realize this is getting really complex, but you can think of the miner has to do a bunch of work. Okay, they have to spend a lot of money, use a lot of energy to find a special random number.
Yeah.
Okay, this is where you hear about these mining farms,
mm-hmm.
and you read these articles about Bitcoin mining, like using more energy than like Iceland. And, right. What these miners are special nodes on the network that have taken a bundle of transactions and now are trying to find a special random number. It's actually a nonce. Now once they found that special random number, by the way, it changes every time. So you can think of it as a race. Like they're all trying to find the next block. All these different miners are competing against each other, using all this energy to try to find this next block or bundle of transactions.
Yeah.
Once a miner has found that random number, they will attach it to their block. There is a hash for a block.
Yeah.
And the hash includes that random number.
Okay.
And the hash.
Yeah.
Yeah. So the block when you construct a block, it has all these transactions. It has this nonce, this random number that they're trying to find, and the block has a hash, which is a hash is a function over a bunch of data, and it generates a number. So it says you can think of it as a random number that you take a bunch of data, a bunch of files, or in this case, a bunch of transactions in the nonce. You run it, you apply this hash function, and it spits out another random number. And anyway, so the blocks have a hash. So they find this special number. They find this special number. They generate a valid block, and then they send that block to all their peers. And there's a competition to find this block. And all their peers take a look at the block. They look at the transactions. They look at that nonce, that random number. They validate it. And if it looks good, then they take all the transactions in that block and update their local database and say, okay, so Hossein deduct 1,000 pounds, Julia add 1,000 pounds, and they execute those transactions one by one locally and send the block to all their neighbors, to all their peers. And then the block propagates throughout the entire network using this broadcast, and they all update their local databases. And then there's a new competition to find the next block. And the blocks are linked together because when you create a block, you specify the hash of the previous block. And that forms a chain of blocks, which is where you hear the term blockchain.
Sam, another question in between, and it's going back a little bit. It's not, like we're talking about the nodes, and you said, there's some special nodes, and they actually do the mining. Does that mean not every node, so not every person or whatever involved in that network is automatically also mining and kind of verifying transactions? Is it just like a few specific ones?
That's right. Yes. So mining has now become a very expensive, computationally difficult task. So it takes a lot of money to mine a block. So only a few organizations. Well, it's probably. Realistically, in Bitcoin, there's probably a dozen organizations that mine 99% of the blocks. So only a few groups of people actually run mining pools and actually mine to find blocks. Now that doesn't mean everyone else validates every transaction. So when they get a block, suppose you run Julia, suppose you download Bitcoin.
Yeah.
You're running your node and you're not mining because it's too expensive. It would just sort of waste power. But you still want to be able to create Bitcoin transactions and validate Bitcoin transactions. Your node will validate when it receives a block or receives a transaction. It will validate it immediately, and you won't update your local database unless it's valid, right?
Okay.
So you still perform. It's called a fully validated node. You still perform validation, but you're not entering this competition to find a block. Okay. Yeah. So the consensus protocol in Bitcoin is called proof of work, and that's where you're trying to find. It's this race to find this random number to this nonce that is mathematically difficult to compute, meaning in order to find the block, you have to spend a lot of resources, right? And your node, anyone's node, not just miners, they only accept blocks that have done that mining, that have gone through that hard work of spending energy to find the block, right? So if you take a step back and think about this, like you create this economic system where people who do the work to find a block end up having to spend resources and are incentivized to protect the network. And so sort of the genius behind Bitcoin is that it's sort of it's the first time that someone proposed a consensus algorithm, a rule for reaching agreement that was based on economic and financial incentives, where you have a financial incentive to maintain and to do the right thing and not create fake blocks. Because it's if you go to all the work to mine the block and it's invalid, like it's a double spend, then all the other nodes in the network will just reject it, right?
Yeah.
So it's not a leader election based thing. It's this other thing where you have to mine and spend energy to find the block. That costs money. So if you were to actually attack the network, you have to spend a lot of money to attack and create these fake blocks, and they might not even be validated. They might just be rejected by everyone else on the network.
Okay, so basically the good thing about it is not only the fact that when people want to kind of hack or like fraudulently use the system, that others would reject it, but additionally to that, you're kind of incentivized not to do it because you would additionally use all this energy and in the end money basically to go through all that work that in the end is going to be rejected anyways.
That's right. Yeah.
Okay.
So it boils down to in economic, everyone's financially incentivized to behave correctly and maintain this database that's correct. And so the proof. So really, like, the proof of work. Taking a step back, just going back to the beginning, it was needed because you don't know the identities of the people participating. So you can't use like some kind of election-based system. And that's why Bitcoin has this like what they call pseudo-anonymous guarantee. So what that means is you can see in the Bitcoin network, you can see all the transactions. Anyone can see all the transactions, and that means you can see the transaction amount, you can see the timestamp, you can see the sender wallet and the receiver wallet. You can see all of that. Now, the wallets are just these random numbers, so you don't know which real-world identity owns that wallet, has the private keys, or can spend those coins for that random number. But you have the entire transaction history available to you. All the nodes do, right? So they call it pseudo-anonymous. It's not fully anonymous, because a fully anonymous system, you wouldn't be able to see any transaction details, right?
Yeah.
It's pseudo-anonymous because you see transaction amounts, you see the timestamps when they happen, you see these wallet identifiers, but you don't. It's pseudo-anonymous because you don't know who belongs to that random number. Now, Bitcoin, because of this pseudo-anonymous, people say it. You'll hear this a lot. It has these censorship-resistant properties. Basically, what that means is that someone with, I don't know, I saw this like a few years ago on the news. It was during like some of these protests that were happening in Ukraine. Like, people can just put up a Bitcoin QR code, like their hash, on the news, right? And someone on the opposite side of the world in the US, in the comfort of their own home, can send that person money, like instantaneously, right? That's a pretty powerful thing. Like, up until Bitcoin, you couldn't do that. If you tried to do it through PayPal or some other system, like PayPal could just reject the transaction. Or if you went through the regular, Swift or whatever, like, they're not going to let you send transactions to like random people in Ukraine anyway. With Bitcoin, it's censorship resistant. There's no government entity that can stop you that can prevent your transaction from getting validated
and placed in the blockchain.
Yeah.
So that's a whole, like, that's really the core part of Bitcoin, and why you have proof of work is so you can have these censorship resistant transactions, and it's a very powerful thing, both for good reasons and for bad reasons. Like our cybersecurity paper talks about this. You know, it can cause a lot of problems, right?
Yeah.
Too. I mean, it's powerful in the sense that, like, you know, you see transactions where people are sending $30-40 million, 10 minutes, you know, around the world. Who knows where it's going, right?
Yeah.
That's super powerful. It can be bad, you know, it's pseudo-anonymous, so you see new types of crime where you have, you know, ransomware. Ransomware could not exist before Bitcoin. It just could not exist because if you're going to ransom someone, you have to receive money. You go through your traditional systems. That means they know your identity, so you're subject to, you know, local laws and law enforcement. Mm-hmm. So anyway, permissionless. What does permissionless mean? That means censorship resistant. It means anyone can, you know, download the software, run a node, participate in the network, create transactions, mine if you want. Like, I can, you know, Hossein and I, we could get a bunch of money from investors and just create a mining pool if we wanted to. There's no one stopping us. Now, okay, blockchain, right? So we talked about the mining and the blocks. Blocks are just bundles of transactions that get sent out and then all executed at the same time and validated at the same time. And they have to go through this consensus where you generate this random number that's really hard to generate in order for it to be valid, right? So, and the block has a reference to the previous block. So you end up with this chain of blocks, right? So, interestingly, blockchain, like the word blockchain, never shows up in the Satoshi paper, in the Bitcoin paper. Wasn't a thing. But what happened was people took that idea, the overall architecture, the concepts, the data structure, this idea of having transactions, bundling them in blocks, reaching consensus on the block, you know, connecting the blocks to form a chain. Those overarching ideas and concepts, people started to create other systems to solve other problems, not just payments, not just peer-to-peer payments, to build new systems, to take some of those same ideas and build new types of systems that solve different problems. And so after Bitcoin, you had a number of what are called altcoins, which are just, you can think of them as copies of Bitcoin with slight differences, like they change the way the mining works or they change the types of transactions. Some of them have more transaction confidentiality, so you don't see the payment amounts in the transactions even. So there were a bunch of, you know, copycats that have slight adjustments, and all for public permissionless blockchains. And there was a new type of blockchain that came, type of blockchain technology.
Sam, can I ask one question in between?
Hey, just interrupt me.
When you say this altcoin, isn't there also something where it kind of split from the, like, I don't remember the name, but there's like a coin that is like very similar, but at some point they're doing something different, so it kind of split and it's a new coin. Is that a type of altcoin or?
Yeah, you can think of it. So what you're referring to is a fork.
Yes, that's what I mean. Yes.
What's that?
Yeah, that's exactly what I meant. I just didn't know the name. Yeah.
Yeah. So you can think of it as an altcoin. It's an altcoin where the new coin shares the same exact blockchain up until a certain point. Mm-hmm. So suppose there's a fork tomorrow or a fork today in Bitcoin. Mm-hmm. It's kind of like so there's a new version of Bitcoin that gets created through the fork. There's the old version still exists. There's the new version. The two of them share the same exact transactions, the same exact history up until today. But for tomorrow and beyond, we have different transactions and different histories. That's all a fork is. Mm-hmm. So, I mean, technically it means that the consensus algorithms broke. So in the fork version, everyone, like the people who are participating in the fork, the new version, have to download new software. They can't, the old software doesn't work anymore. They have to use new software.
Okay.
And we can do another session on the difference between soft forks and hard forks and that kind of stuff. But you can think of it as like an altcoin. It's just a new type. It's a new network that has the same history up to a certain point as the old network.
Yeah.
So and then you had sort of Ethereum came on the scene, which expanded the concept of Bitcoin to not just be payments. Now you can run arbitrary business logic in what are called smart contracts. We'll do another session on smart contracts and all that, but you can think of it as like a Bitcoin, a public network, a permissionless blockchain, where instead of just doing payments, you can do arbitrary computations that people agree on.
Okay, so smart contracts only started with Ethereum.
Well, okay, it's interesting. I mean, the notion of smart contracts, like that terminology, and the idea behind it. So it kind of goes back to Nick Szabo, this professor and computer scientist. He's a professor of law and computer scientist who, was writing about, also part of this whole cypherpunk movement, who was writing about digitizing contracts, like in the 80s and 90s. So Nick Szabo is kind of, he is probably he along with Hal Finney are sort of like what most reasonable people would think are possibly a candidate for being the inventor of Bitcoin. Mm-hmm. So, he had a lot of influence in the design and the thinking of this, and had thought a lot about smart contracts and digital contracts in general. Mm-hmm. But he'd done that way before the concept of blockchain or proof of work or any of that stuff came on the scene. Mm-hmm. What Ethereum did was it was the first system to combine blockchain with smart contracts and show that it's a good combination and useful combination. So, and we'll do another session on smart contracts, but you can think of it as it's the first blockchain to use smart contracts, yes.
Okay.
But smart contracts itself is a concept that predates blockchain and proof of work by a long time.
Okay.
So anyway, that's public blockchains. Now, what happened was, so you have Bitcoin, Ethereum, these other altcoins. People started realizing, hey, we can take some of these same concepts and apply them in a private setting where you have where you do know the identities of the participants. You can think of a consortium of banks, let's say, or in our case, like a group of insurance companies. You know the identities, but they don't trust each other. And you can take some of the same concepts, like the idea of transactions and blocks and reaching a consensus to the blocks and synchronizing the different databases, all of that. You can apply the same concepts in a private setting. And that's where the concept of permission blockchains were born. And that happened many years after if you think of like Bitcoin being blockchain version 1, Ethereum being version 2, permission blockchains is sort of like version 3, I guess. So in a private blockchain, it's private, meaning only certain people have access to it, which means like in order to gain access, they have to go through an authentication process, right? Mm-hmm. So that means you know the identities of the people that are participating, right? And so if you know the identities and they're participating, what that boils down to is you no longer need the proof of work. Because the whole you can use other consensus protocols. So the whole idea with the proof of work and all that stuff was to support people, the censorship resistant thing, being able to support a network where you don't know the identities of anyone else, right?
Yeah.
But private blockchain, you know the identities. Only people who authenticate with the network should have access. So like, if you had a group of banks that were executing interest rate swaps, let's say, you would want to make sure that only authorized banks or regulators have access to the network. You wouldn't want to be able to have anyone have access to your network.
Mm-hmm.
In most cases, like that, the idea of that would just like the CISOs of the bank would just be a non-starter.
Mm-hmm.
Like we're not going to open up our network to allow anyone to participate. Like that would be a non-starter. So they were interested in having private networks, having or permissioned. It's a synonym, where you know the identities of the players, and they authenticate, and then once you're on the network, you still don't trust. I mean, they're competitors. Let's say they're competing banks, so they still don't trust each other. So you still want to execute consensus protocols to make sure everyone is in agreement and to detect malicious people. So if Alice starts lying, starts telling you something different than she tells me, the consensus protocol should be able to detect that and kick Alice off the network and say, hey, look, Alice is lying. She's pretending to be two different people or whatever. You should be able, the network should be able to detect malicious activity and isolate it and kick misbehaving participants out of the network. And so this is the idea of private or permission blockchains. This is where this idea was born. Let's take some of the excitement and some of the concepts that came out of the public case and apply it in a private, locked down setting among only a handful of participants. So in these consortiums, there's still no central administrator that's responsible for the whole process. So each participant is kind of like in Bitcoin, like each participant is coming to the table on an equal footing.
Mm-hmm.
So there's no administrator or authority that owns all the nodes, and it's still decentralized. But instead of being decentralized across 20,000 people around the world, it's decentralized across 5 different banks.
Mm-hmm.
Each running their own nodes that are theirs, that they operate.
Mm-hmm.
So it's a different type of. It's like you can think of it as like smaller.
Yeah, like mini.
Like if you have like fully decentralized, on the far left, and fully centralized on the far right.
Yeah.
Where like the far right is like a traditional Oracle database, and the far left is Bitcoin. Mm-hmm. It's sort of like further to the right. It's like not in the middle. It's like further to the right.
Yeah. Okay.
So you still have the benefits of not having a single organization operate the entire network. Because if you took a set of banks doing interest rate swaps, like they all hate each other. They're not going to agree on one bank being the administrator of this process because they wouldn't trust a single third party. I mean, they do. I mean, they have these like swap execution facilities. So I mean, practically speaking, today they will trust some trusted third party intermediary to do it, but they don't like it because they're putting a lot of trust in them. And that person is slowing down the process and extracting high fees. And they can see a lot. They have a lot of sort of information asymmetry. They're seeing information about everyone, right?
Yeah, so I think that makes sense. But at the same time, with many of our clients, like in the insurance sector and so on, there's only one company that uses the blockchain then, right? So it's like an internal system kind of. So there is only one. Yes, there's different nodes, which are like the employees, probably. But there's only one company as such.
Yeah, so it depends on a like case-by-case basis, but what you can see is like if you have a really large insurance company, you might have multiple teams or multiple subgroups.
Yeah.
Each having their own IT department, their own IT systems, each having their own bit, their own part of the process. So it's not the case. So in that case, it's not like they don't trust like, their neighbors in their company, other groups and their teams in their company. It's just they want ownership over their part of the process, and there's no one team that can just take over the entire process from everyone.
And I guess then in that sense, in those cases, it's also more of the other benefits that come in, like more of the other blockchain benefits that come in that are probably even more important than this one, for example.
Right. Yeah. It's not so much of a trust thing. It's more the decentralization piece, not having one group responsible for the whole thing, yet keeping everyone up to date and in sync.
Yeah. Exactly.
And on a standardized technology.
Yeah.
Because typically when we see, like if you go into Aviva, you have all these different groups. They have all their different teams, their own different IT departments, their own different database technologies. Each person does their own thing, and then you have a bunch of point-to-point custom integrations between these different systems.
Yeah.
And so because like there is no team that's responsible for the whole process, there's no visibility into no one has visibility to the entire end-to-end process. So what a decentralized technology can give you in that situation is it can make everyone on the same page, so everyone can have visibility into the entire end-to-end process, but they don't have to give up control. They can still operate their own nodes and have their own IT infrastructure without having to have the separate centralized team that manages the whole thing.
Yeah. Okay. Makes sense.
That starts to get into like smart contracts too, which will one of the next sessions we'll do.